Okay, so this is lesson 23, second day of parent, family, child. We went through all of this information about what A, H, and K are, how to find a parent, and we said that A is our amplitude, and remember the amplitude tells us how tall or shorter that our graph is going to be, and that means it's stretching or shrinking. And if I stretch or shrink a graph, I'm only affecting which value, X or Y? The Y's, because the Y's go up and down, right? A, guys, is not always going to be positive. It's not always going to be a 2 or a 3 or a half or a 1/3. It can be a negative 2. At this point, we're going to ignore the negative and look at 2 and say, is 2 bigger than 1? Yes. And if it's bigger than 1, it's going to be a stretch. If it's less than 1, it's going to be a shrink. But if it's negative, that's where, change here, we say it's reflected about the x-axis. That is, if you need to put a little note here, when A is negative. If A is negative, we state it's reflected about the x-axis, and we can kind of leave it at that. We ignore the negative sign from there on out, and just like I just said, if A is bigger than 1, that's a bad greater than. If A is greater than 1, it's a stretch. And if A is between 0, that's an A. If A is between 0 and 1, what is it? It's a shrink. It's going to get shorter. Right? So that's what's happening there. That's how A affects our graphs. And here's the thing. If it's only affecting my Y values, I'm only going to multiply those A values to Y. So to get from the parent to the family, going in this direction, I'm going to multiply Y's by A. There's a lot of information on this page. I know it's going to get a little confusing, okay? So hopefully you guys can organize it in maybe a little bit more organized fashion. I'm kind of stuck to this screen. Okay? And when we get to the example, it's going to make a lot more sense. So I'm going to multiply just the Y's by whatever A is. If A is 2, we multiply the Y's by 2. We leave the X's alone from the parent. If it's a negative 5, we multiply all the Y's by a negative 5. Okay? We're doing our multiplication first. Then we said that H and K starts talking about our left, right, up, and down movements. I'm going to add or subtract. So when I get to my H and K, I'm going to add or subtract H units. Now wait, H is associated with which variable? Look above in the equation. Which one is it next to? It's X minus H. So it's associated with X's. So if I have an H value other than 0, I'm going to either add it or subtract it. If I go left, I'm going to subtract. If I go right, I'm going to add. It's just like our number lines, right? We'll already establish from above that if you see X minus 2, it's going to the right. Or X plus 2, it's going to the left, right? We already established that point. Once we establish we're going left or right, if we're going left, we're subtracting. If we're going right, we're going add. So you add or minus H to X's. K is exactly the way you see it. So if you see plus 2, you're going to take all your Y values and add 2. So it's plus or minus K to my Y's. Record again. These words here have to be part of our problem. They have to be on our bridges. I call those the bridges to go from the parent to the family, to the family, to the child. If something's not there, so I don't have an H value, so it's just 3 to the X, that means I am not translating left or right. I don't need to state it, and I don't need to do anything to my X's. Just like, not there, here we go. If it's not a negative A, I'm not going to say anything about reflecting about the x-axis. You only have to state things that are there. That's like putting a 1 in front of x. Do we do it? No, we just say x. We don't say 1x anymore. Okay? So let's get into a problem. This problem here, which is y equals 2 times 3 to the x plus 5 minus 1. Again, looks complicated. I call that the child. I'm going to do a two-pronged approach to this one. First of all, I want you to state the words that we normally would put on the bridge. We have to put on the bridge is vertical stretch or shrink. Is it reflected? Is it translated left, right, up, or down? And how far? So I want to see that first. Then we're going to go through the whole parent, family, child. I'm not always going to have you state all that stuff first, but I want to do that first so you guys can see where they fit and why it fits. So, essentially, if I had the parent, which is y equals b to the x, those things you graphed yesterday, what is the parent of this one? Because that's the one we're going to base it off of. We're not basing it off of just b to the x. We're basing it off of that parent to this problem. What is it? Y equals 3 to the x. So y equals 3 to the x power. That's the parent. We're going to base it off of this. Now, is this growth or decay? It's growth. So, it's kind of nice. State some information. At this point, we know a parent, we know its growth. We probably are already starting to think about what that extra point is going to look like, right? We already know the other information. That's part of the process. But let's use our words. We know that it has a 2 in for A. What does that 2 tell us? It's a vertical stretch of how far? 2. Vertical stretch of 2. I'm just going to list it. What else was brought into this problem now? What's my h value? It's a 5. Is it a 5 or a negative 5? It's always opposite of what you see. So it's a negative 5, which actually means it's going to be translated. Ooh, careful. Translated 5 to the left. Positive 5, it looks like, because it's x plus 5. You're thinking, oh, I'm going to go to the right because that's positive. Oh, wait, it's with the x's, it goes in the opposite direction. It goes to the left. Because remember, it is a negative 5. A negative 5 goes backwards. And k is exactly the way you see it. It's translated. K translates which way? 1 down. Because if I subtract 1, the graph will go down 1. Those are the words that I'm eventually going to put on the bridges. Yes. I would say, I'm not going to have you list them all the time, but you have to write them on your bridges as part of the parent, family, child method. So I'm going to start the process now. I understand we already wrote down the parent. We already wrote down that it's growth. But I'm going to start the process from the start to finish. And I always start off by saying parent and listing it. What's the parent again? 3 to the x. And we know things about parents. As we like to say, or I like to say, all parents stay at home so that they are pretty consistent here. We talked about this in the very opening of the day, going over the problem. They all have an asymptote where? Y equals 0. We all have a y-intercept 0, 1. And we all have, or we need, the extra point on the tail, right? And this is growth, we said, so we pick a point where? At 1, positive side. And what happens when I plug 1 in for x? You get 3, because 3 to the first power is 3. Everybody should be able to understand that. Does everybody get that? Because this is where we actually are now going to use the method. I am not going to just come up with my own points to graph something. I am going to graph it based off of that set of points and the information that we stated above. Okay, here we go. The parent is going to go to the family to talk about it. So, what's the family? Let's go back here. Family. Y equals A times B to the X. So therefore, what's A? 2. We should have Y equals 2 times 3 to the X. Yes? Yes. What did we say happened with that 2? What did that 2 do to my graph? It made it taller by a factor of 2. So we say it's a vertical stretch of 2. Okay? Now again, normally I don't have you list them above. The words would actually be on those bridges as we go through the problem. Now watch this. This is really cool. I still have an asymptote. I still have a point and another point. They're going to be changed though. I just took them, put my foot on it, and pulled up, didn't I? I'm stretching it. And when I stretch it vertically, does it change my x's? No. It changes my y's. So guess what? All of my x's are going to stay the same. Y equals. Is there any x's in that part? No. How about the first point? 0. Is that going to change? No. What about the next one? 1. No. I'm not changing any of my x's. I am changing the value of my y's by a factor of 2. And like I said on the last slide, I'm doing what? Multiplying the y's by a. And a was 2. What is 0 times 2? Still 0. What is 1 times 2? 2. What is 3 times 2? 6. You now have the family. If there was no h's and k's, we would stop here and graph those 3 points, swoop in the curve, you're done. But there are h's and k's. So we got to keep going. Does everybody understand? What am I doing here? I'm going to write on the side. We don't normally write this, but you can. Multiply y's by 2. I'm just kind of squeezing that in there. Write it in there lightly so you guys can say, oh, what did I do from here to there? We now go to the child. The child is the original equation, yes? It has all those moving parts. Children move around quite a bit. I know, it's an experience. So, 2 times 3 to the x plus 5 minus 1. Guess what? It still has 3 pieces of information. It has y equals, it has a point, and a point. I didn't like that point. Okay? The 3 pieces of information are still there. We are now going to pick them up and move them, though. How are we moving them again? What's the words? Translated 5 to the left. Yes, I want to see translated 5 left. Or you could say left 5. I'm okay with that. But I still want to see translated. Translated. Oh, it's bad. Translated 1 down. Notice that I didn't have to have you list them in the beginning. I could have had you just put them on the graph or on the chart because that's where they go. Now wait a minute. What does it mean to be moved 5 left? That affects what? x's. Left and right is x. So what am I going to do to all my x values? Minus 5. Is there an x value associated here? Not with y equals, that's y. And so, now, 0. 0 becomes negative 5. 1 subtract 5 is negative 4. So what was the words we want to put in here? Maybe subtract 5 from x. It's kind of hard to write sideways on this without it flipping on me. So I subtracted 5 from the x's. What am I going to do with the y's? Subtract 1 from y's. So now, we did have a 0. We had a y value here. So it's not y equals 0, it's y equals negative 1. It's not 2, whoops, wrong one here, 2, it's 1. It's not 6, we subtract 1, it's 5. Guys, guess what? All you have to do is plot those 3 things and swoop in a curve. You're done. Just those last 3, because that's the information for the child. The process, if done and you're following this, you multiply to the y's and then you can add, subtract to the x's and y's. It's not necessarily a hard process. Does it take some time? Does it take up a lot of space? Yes. But okay, guys, I ran a half marathon. Okay, jogged it. If you were giving me the option to jog it or walk it, which one's going to be easier? Walking. It takes a lot longer, okay? Both are going to get you there. Both will have you finish the race. This one is a little bit longer method. Now, let's graph that information and talk about why I want to do it this way than, say, just making a T-chart. Because I think we can make a T-chart, fill it in, we're going to be fine. But there's a reason why. I'm going to squeeze my graph in the space above here. Let's see. I got x values going to negative 5. So 1, 2, 3, 4, 5. Okay. My y asymptote, or my horizontal asymptote, is at negative 1. I'm going to change colors so we can see it. I think everybody should agree. There it is, yes? And then I just got to plot my points. My first point is at negative 5, 1. 1, 2, 3, 4, 5, 1. And the other point is at negative 4, 5. Way up there. Do you notice that the negative 4 is slightly to the right? So what's going to happen? You would have to go this way. I have to extend my asymptote out. Do you notice that this graph, normally on our parents, were always really close to 0, weren't they? It got moved back 5 and moved down 1. And it was stretched out by a factor of 2. If I chose, guys, to use a T-chart with the values between negative 2 and 2, which we like to use a lot, right? I would have to end up finding something way up there. And you know what it's going to look like? It's going to look like a line. Is that a line? No. It's an exponential curve. And if I don't include the right places where it's going to interact with that asymptote, I'm not going to get the full picture. It's kind of like making a parabola and only have half of the parabola. That's not the whole picture. So you need to recognize that the parent, which we'll graph the parent here. The parent was y equals 0, 0, 1, and 1, 3, right? You guys don't have to do this. I'm just showing for demonstration. There's your parent. Can you guys visually see that I was moved back 5, down 1? And it kind of looks like it's a little bit stretched out there. That's what happened. And again, this process, I can change the parent. I can give you new pieces of information to put in. You follow the procedure, you're going to have the right out. And you can go graph many different types of functions. You guys ready for this? Okay, I'm going to pause the video, give you guys a couple seconds here. Try this one on your own. It's not going to be a lot of time. Try to set it up. Here's the thing. You guys don't have to make the list first. Just put the list in the problem. So, it's decay because 1/3 is less than 1. The negative on the 3 means what? That it's not going to open up, it's going to open down, or what we're going to call reflected about the x-axis. So, what's the parent? Parent is y equals 1/3 to the x. All parents have y equals 0. Y-intercept 0, 1. This is why I gave you guys those problems yesterday, and it said it shouldn't take more than a minute to write down what the parent is. Because it doesn't. And then you got to have the extra point. This is decay, so we're going to choose what? -1. And when I put a -1 on a fraction, it takes the reciprocal, which makes it 3, which makes a nice number. No fractions involved. I like that. I like it when I can avoid fractions. We build our bridge to the family. And the family is what? -3 to the 1/3 to the x, correct? We have to state two things on this bridge. Now remember, the negative, we could ignore and look at the base number there, which is what? 3. And is 3 bigger than 1? So therefore we know it's going to be what? A stretch. Okay, so remember the negative only affects opening up or down. So it's a vertical stretch of 3. The negative is going to say, or tell us that we need to say it's reflected about the x-axis. It's reflected about the x-axis, which means it doesn't open on the top, it opens on the bottom. And we'll highlight that when we get to the child graph and actually see that it's on the bottom of the x-axis or on the bottom of our asymptote instead of on top. Keeping things consistent. I know I've got an asymptote and 2 points that need to be filled in. I am basically going to, from the parent to the family, multiply what by what? Blanks. What are they? Multiply -3 to my y's, or my y's by -3. That means I'm not changing x's. So I go back in and fill them in. 0, -1, right? And now just multiply all of the values of my y's by -3. 0 times -3? Still 0. Not going to affect it. Guys, here's a hint. Hint, hint, hint. On the family, it's always going to be y equals 0 still. Because no matter what I multiply to 0, it's always going to be 0. And 1 times -3 is -3. And 3 times -3, -9. Any questions, guys? Please ask them. And now I got to get to the child, right? Do we have two things going on for this one? Do we have an h and a k? Yes. And the equation is -3 times 1/3 x plus 2 plus 1. This one should always be started off with translated. It's to left. Why is it left? Because it's opposite of what it looks like. It looks like positive 2, but it's actually a negative 2. And it's translated 1 up. Because that one is all said and done after everything. So you're going to go up 1. Again, how many pieces of information? Just the 3. Let's start with my x's. I'm going 2 to the left. So 0 becomes negative 2, and negative 1 is a negative 3. And all my y's, I'm going to go up 1. So if I'm at 0, I'm at 1. Negative 3. And graph it, you're done. I think I got enough room on the bottom for this one. Now guys, look at your numbers when you go to make your graphs. I got a negative 3 and negative 8. So I'm going to definitely be in the, what's that, the third quadrant. Okay. So when I go to make my graph, I'm going to be kind of heavier on the bottom here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And I have to go up 1, don't I? I'll change colors. My asymptote is at y equals 1. Negative 2, negative 2. And negative 3, negative 8. Now, don't draw this one. If we didn't reflect it, our points should have started tall and went this way, yes? But what I'm doing is I'm folding the paper in half and then kind of copying it to the other side. What happens is the other way. I don't think it's a difficult task to fill it in. And it's always the same. Multiply the y's by whatever that number is, and then add or subtract according to going left or right, up, down, to my h and k, or my x and y's. And you just have to plot the last bit of information. Okay? Questions, questions, questions. I got one more example. We're not going to go through the whole thing. We're just going to talk about this one. And then I got a worksheet. You guys have a worksheet because the book does not go as in depth as all of this in this lesson. So, okay. Let's just talk. Let's talk about all the different aspects about this. Growth or decay? Oh, wait. Growth or decay? It's growth. Why? Because the 3 is the base and it's bigger than 1. Vertical stretch, vertical shrink, or none? What's A? It's a half, so therefore it's a shrink of a half. Do I have to state that it's reflected? No, because it's y. No negative, it's positive. Okay. Moving on. Translated 3 to the right this time, which means I did take all my x values and add 3. And because of the x minus 3, it's always opposite. So I'm going to add 3 to my x's. And this one says I'm translated 3 up. So I'm going to add 3 to all my y's. Again, that's what you go on the bridges, and you can go from there. Okay? Your homework is the worksheet that is going to be handed out, and I'll post it on Haiku. Have a great day.